So now we've seen arithmetic expressions, we've seen giving names to those, we've seen how we can combine those together using names in places where we would use values. We can start doing some simple computations. But those are all dealing with scalar objects, numbers. Let's talk briefly about other kinds of objects. We'll come back to them later on, but we want to see what we can do here. So non-scalar objects are compound things, things whose portions or components we can get at. We'll see a lot of these throughout the course of this subject. But the simplest one to start with are what are called strings, or objects that have a type str for string. And these are literally just sequences of characters that are all concatenated together. So, how do we write them? Well, literals of this type can be written either by putting them inside of a single quote or putting them inside of double quotes. And so if I go to my Python shell, for example, we can see that we can put things within a single quote, and that gives us that string back. By the way, we can give names to those things. So we can say, what's the value of foo? And in fact, we can look at the type, and we'll see that it gives us back something of type string, or str. And by the way, we can also put quotes around numbers. So this is a string. And just to see that, let's ask for the type of that. The type of that sequence of characters, numeral 1, numeral 2, numeral 3, inside of the quotes, is a string. And that is different than the type of the number itself, which is an int. So, we can put together strings. If we can put them together, we'd like to be able to do things with them. And I want to show you some examples of those. So we can provide different operations on strings. Now, some of these may be a little surprising, so let's walk through them. The first one is we can ask for taking the string A and multiplying it by the number 3. And that may sound strange, but what it gives us is a string with 3 copies of A's stuck together. Or, if you like, I could do it with a slightly more complicated string, and it literally is just concatenating or copying those versions of those strings together. We can put 2 strings together using addition, give us this concatenated string of A and B. And we can, of course, also concatenate together strings if we wanted to make sure that they are converted into strings. So we could take a number, convert it to a string, and concatenate that together to give us the string A123. These are just different ways of dealing with strings and putting them together. It seems a little odd that we're using operators that don't normally deal with numbers, and this is an instance of what we call operator overloading, in which what we are doing here, here, and here is we are using the same operator to do different things. If we give them numbers, it'll do one thing. If we give them a number and a string, in the case of multiplication, it will do something different. If we give them 2 strings, it will do something different. So we're letting the operator use the type of the object to decide what the right operation is to do. The last one we show here is that given that we say we now have a non-scalar object, we need to know how many portions are there inside of it. And for that, there's a built-in Python function called len for length. And if I want to ask for the length of a particular string, it gives me back that answer. So I now have compound objects that I can do things with. Well, obviously, one of the things I'd like to do is not just put them together. I'd like to get parts out of them. So that leads to the interesting question of how do I get out elements of a compound object like a string? And here I want to show 2 examples. The first one is we can do what's called indexing. And let me show you an instance of this. If I give the string ABC, notice the single quotes around it, so that is a string, and in square brackets or braces after it, I give it an integer like 0, it's going to give me out the element of the string corresponding to that index. Now, how does it do this? Well, it starts by, if you want to think of it this way, counting from 0. So, there's the string, the 0th element is that one, and it will return that value. Similarly, if I say from the string ABC, give me the 2nd element, it starts at 0, 1, 2. There's the 2nd element, and it returns that string. Now, I have to be careful. If I ask for the 3rd element, remember I start counting at 0, There's 0, 1, 2. The third element, oh, there isn't one, and we get out an error. And we can see this over here. If I, for example, just type it into Python, I can say, give me the string ABC, and I'll take, in this case, the first element, and that will give me B, because I start at 0 and go to 1. Now, I can also, though, go backwards. So if I have a string ABC, and I give it in square brackets or braces, a negative number, it basically starts at 0 and then counts backwards to -1 and then to -2. So that -1 index will return as the C. So it basically starts at the back end and counts backwards. So we can get out components of strings, which is good. Now, sometimes we'll want to get out not just a single element, we'll want to get out a substring of a string. And for that, we have a technique called slicing. So if we have a string called S, then this expression here, where we have two expressions, a start and an end, that are both integers, or their values are integers, that denotes the substring that starts at the index pointed to by start and stops just before the index pointed to by end. So just to see that, I again take my string ABC, and I say, give me everything starting at 1 and stopping before the third index. It returns for me the string BC. We're going to come back to doing things with strings later on, but we wanted to let you see that given compound or non-scalar objects, like strings, not only can we combine them together, but we can also get out pieces of them, either individual elements or subcomponents of them. And we'll use that as we start doing more interesting things moving on.